Algebra 1, Common Core, Unit 4, Section 1, Solving Linear Equations. So the last couple of chapters, chapters 2 and chapter 3 of this series, we're working with polynomial expressions of adding and subtracting polynomials, and then multiplying polynomials, and then factoring polynomials, which is kind of like dividing. So now we're going to take those polynomials and set them equal to something and solve them. So we'll be solving equations in this unit here. And, I'm sure no matter what level of math you're at when you're watching this video, you have experience solving equations. So this one is going to be pretty basic here. That how do we solve an equation? What are we doing when we solve an equation? Well, the goal of solving an equation is to get the variable alone and to have a coefficient of 1. For example, like I'm going to take this equation here in this demo, and I want it to get to the point of x equals 3. When I say x equals 3, notice that on the left side, or it doesn't have to be the left side, but on one side, x is alone. There's no number over here with it. It's not 2x, it's not x plus 2, it's not x squared. There is a coefficient, it's 1. There is an exponent, it's 1. But when we have coefficients and exponents of 1, we don't necessarily have to write them. You can, you just don't have to. So that's what the goal is. The goal is to get it to be 1x to the first, nothing else over there. And what it equals then is what it equals. And this is kind of a more advanced example, so I'm going to work my way back up to this. But, the steps here are correct, that I want to try to remove any parentheses, see if there's any distribution, and I want to, clean up the sides first. So same side, combine any like terms. Well, maybe I will go through this demo here. So this first thing we did was we saw a parentheses and distribution, and that brought us to this stage here. And then the second step is combine any like terms on the same side. So on the left side, look for like terms. On the right side, look for like terms. I do have like terms like 6x and 2x. Those are like terms, but they're on separate sides. I am going to combine those, but before I do that, I want to combine any like terms that are on the same side. So just on the left, do I have any like terms? On the left, yes. -8 and +3, they are like terms. And because they're on the same side, you don't need to worry about any changing of signs or inverse operational stuff. Just literally combine like terms. A -8, +3 combines to be a -5. On the right side, there are no like terms. So that's why the right side was 2x plus 7, still is. Then you're going to do the inverse property of things to move things from one side to the other. So now I'm looking at combining like terms that are on separate sides. Here I have 6x and 2x are like terms, -5 and +7 are like terms. But this is where it gets a little bit more complicated because, let me zoom in a little bit. To combine like terms on opposite sides, you can't just combine them. Like I can't just take this 2x, bring it over here and make it 8x. Because equations are balancing acts, and if I'm going to add 2x over here, then I got to add 2x over here, but then that makes this 4x. And how does that help? Because I'm trying to only have one x term. So I have to figure out a way to move this term and combine it with this term, but also eliminate it over here at the same time. And that's where the inverse concept comes up, is to move something from one side of the equal sign to the other, you do the inverse operation, meaning this is a +2x. Well, I could cancel it out on this side by subtracting 2x, because 2x, 2 minus 2 is 0. That'll cancel out. And I can do that same thing over here. And so that's how, if I have a positive term, I could bring it to the other side as negative. And that's what you're seeing down here too. -2x minus 2x, this cancels out. And then the 6x minus 2x is where we get the 4x from. For the constants, the -5 and the +7, it's the same thing. Now I'm going to decide that because I want x on the left in this case, I'm moving this x term to the left, then it makes sense to move the non-x term, the constant, to the right. And the way I can move this -5 to the right is, again, what's going to cancel it out? Well, a +5 will cancel it out. And so I do +5 on both sides. And that's what you see here, is I'm adding 5 on both sides. It's canceling out here, and 7 plus 5 is where the 12 comes from. And then when you get down to the 4x equals 12 piece here, you can just, this is 4 times x. The inverse of that operation is divide by 4, and that's where x equals 3 comes from. Very easily check your answer by plugging it in. Just replace your x's in the original equation here and here with 3. And that's what you see here. And do a little bit of algebra, and you'll end up getting the left side equaling the right side to be the same thing. It's not always 13, but it's going to hopefully be the same number on both sides. That's how you check it. All right, so here's a couple of practice problems. This first one is a very basic two-step equation, it's called. And the only like terms you have are the positive 5 and positive 17. Well, on the left side, I have x. There's no other x terms, so I'm going to keep x on the left. And I want to move everything else away. I'm going to write this bigger. So 2x plus 5 equals 17. I'm trying to get this alone. So what's happening to x over here right now? Well, right now it's being multiplied by 2 and it's being added by 5. Well, I need to do those inverses to move it away. And we first deal with addition and subtraction. It's actually a form of reverse PEMDAS. So I add and subtract first instead of last. So to move this plus 5 to the other side, I'm going to minus 5, because this way it will cancel out here, and then I won't have any numbers on the left, and all the numbers can be combined on the right. And so 2x is still left. 17 minus 5 is 12. And now all I have on the left is 2 times x, so the inverse of that would be to divide by 2, and x equals 6. Hopefully this seems very simple, and you've known this probably for a couple of years, but if you honestly can get really good at this, it's going to make a lot of the things that are coming up in the next few months a lot easier. All right, how about this next one? Because this is where a lot of the common mistakes come from. Just simple things like people forgetting to, mess up, inverse operational stuff. They're adding 5 to both sides instead of subtracting 5 to both sides, things like that. But remember, you could always check it. Just plug in a 6. 2 times 6 plus 5 equals 17. 2 times 6 is 12. Plus 5 equals 17. 17 equals 17. Check. All right, next one. Here we have a couple of sets of like terms. Again, I have variable terms, and then I have constant terms. Well, I want to move the variable terms together. I'm going to choose to move the x's to the left again. So I'm going to move this term by adding it, since it's negative, over to here. And 6x plus 2x is 8x. Minus 3 equals 13. And now I'm at the point where I was in the last problem. It's a two-step. Move this constant to the other side. Because it's negative, I'll add 3. Add 3. 8x equals 16. That's 8 times x. Divide. Divide. X equals 2. Plug it in and check it. It's going to work out. Last one. Similar to the example we had up there, you see this parenthesis set. We know that this means 5 times this. Well, it's usually easier to get rid of any parentheses first. So I'm going to multiply this distribution out. That's 5 times x is 5x, and 5 times 3 is 15. Then I have a minus 3 equals 7x plus 6. And, it wasn't an issue for the last two examples, but I want to do same side simplification first. There wasn't any involved in this or this, but here I do have same side simplification. The common mistake people make here is they think, oh, I got a, minus 15. That, the only reason you would change the sign of this 15 is if I wanted to move it to the other side. If I'm combining things on the same side, don't change any signs. Just combine them as they are. Positive 15, negative 3, that combines to be a positive 12. 7x plus 6. Get my like terms together. Now here, I've been moving my variables to the left, but I could move the 5x to the right side if I want. And sometimes people will do that. They'll say, I want x to be positive. Because if I subtract 7x this way, I'll get negative 2x. Well, if I subtract 5x this way, I'll get positive 2x. But it really doesn't matter. I mean, you may have to divide by a negative, but that's okay. I like x on the left. So I'm going to move my x terms to the left, and that's going to mean minus 7x, minus 7x. And this will end up giving me a negative 2x. Plus 12 equals 6, because this cancels. And I'm going to move my constants to the right. That plus 12, I'm going to minus 12 on both sides. So it cancels here. I get negative 2x equals negative 6. And you guys still got to be careful with your basic algebra of combining signs and combining terms. And then this is dividing by a negative 2. And a negative divided by a negative is positive. So x equals a negative 2. X equals positive 3. And again, you can very easily plug it in here and check, but I don't want to take up too much of your time. You could plug it in yourself and verify that it checks. All right, so that's our first example of solving equations. This is solving basic linear equations, Unit 4, Section 1. See ya.